We're fortunate tonight to have Larry Crumpler as our speaker. He's a volcanologist at the New Mexico Museum of Natural History and Science. He's been working with NASA for years on several rover missions to Mars. He advises NASA on the geology of Mars and where to look for interesting stuff. And he's writing a book about Mars, summarizing 50 years of Mars exploration. He describes himself as the Forrest Gump of Mars information, and he's doing a deep dive back to the 70s when basically we didn't know anything about Mars. And recently he was picked as one of just over a dozen scientists by NASA to be on the science team of the Perseverance Rover mission. And so I'm hopeful he'll tell us all about that. So without further ado, Larry Crumpler.
Okay, I'm going to share a presentation here. And so, so this is mainly a presentation about what we've been doing for the first 238 days on Perseverance. And the along the way, I hope to kind of touch on a few of the issues that we have in science periodically about how you know things and when do you not know something and what do you have to do to really know it. And of course, that gets at the the question about how people are always coming up with these crazy ideas, these UFOs, the aliens and things, and it kind of represents a question of what is your your bar for assuming that you know something. And of course in science it's pretty high, but even in the sciences there are variable levels depending on your background and your understanding of things. And so I hope I might sort of interrupt my own talk and actually shorten it a little bit in order to discuss that topic in a couple of places. But mainly this is about the rover Perseverance, which just landed in February of this year. And there's a fairly large science team, and as Dave pointed out, 13 of us were selected to be, participating scientists on this. It was a competitive selection process. And so I proposed to do basically what amounts to field geologic mapping on this mission. And that was a winning proposal. And so I'm on the Perseverance Rover, something that's very kind of difficult to do these days. There's so many people who want to go to Mars or be on Mars missions. So anyway, this is about our first 238 days on Perseverance. And so without further ado, I'm going to start the presentation here. Um, so one of the big things is, how did we get to where we are with our knowledge of Mars? Um, the the thing is that, for a couple of thousand years, we really knew very little about Mars. It was just this red star in the sky that moved around strangely. And then in the beginning, maybe the 19th century, we started having telescopes where we could actually observe the surface. And our view up until the 1950s was pretty much what we see over here on the right, just kind of a blurry disk with strange dark blotches. And of course, for a long time, we knew that there were like white, what appeared to be polar caps, and that was pretty much our view up until the space age. And the result was that we had maps that looked like the right half of this hemispheric view in the center of the slide here, where we had blotches of dark and then sort of the rusty tan color that characterized most of the surface of Mars, gave it that red color that we see in the sky. And that was our view. And of course, that led to all sorts of interesting ideas. The human eye plays tricks and saw a lot of these blotches as being connected, with lines and so on. So that led to the idea of that Schiaparelli had, that these were lines on the surface, and then that Lowell took it one step further, of course, and assumed that it was an alien civilization building canals on Mars and so on. And so these blotches and streaks on Mars were very important for a long time. And Mars is good at playing tricks on us, that basically it leads us astray. It gives us something. We think we know something, and then suddenly we don't. So we thought we knew Mars as this place that had these blotches and streaks. And then in the early 60s, we started sending spacecraft to Mars. And that's when we learned that Mars is actually this exciting geological place that has volcanoes and canyons. And later, of course, we had even higher resolution orbital images that showed, layered sediments and basically, a really complex place with lots of geology. And and then even later, of course, we've landed on the surface. We're actually looking at the surface, looking at the rocks up close, the same way you would do if you walked out your back door and looked at some of the rocks here in New Mexico. So we developed this totally different view of Mars, and so the bottom line, the moral of the story is that all these streaks and blotches were absolutely meaningless. They were simply surface features resulting from places where the rocks were a little bit more exposed, and therefore the surface is darker, and places that were brighter because they were more dust covered. But we couldn't resolve the real geology. So it was, in this case, our level of understanding was a question of our resolution, our ability to see what was really important, which was, of course, the surface and the actual physical planet. So that's kind of a lesson that we keep learning about Mars. We think we know something, and then when we look a little bit closer, we discover that everything we thought we knew was not really important. That was just a distraction. And that was probably the classic example, or transition from pre-space age to space age. So, so how did we get to this point where we understand Mars so well? Well, we've had a number of missions over the years, and of course, beginning in '64, we had Mariner 4 fly by. I know I was sitting by the radio waiting for results as Mariner 4 flew past, and of course, there was no results reported in those days. We didn't really have big media interest in the planetary exploration. I think in a couple of days later, some of the images came back in the front page. Mars was a dead place, lots of craters and so on. And we kind of stayed there until the early 70s with the Mariner 9 mission, when we first learned that there was actually a lot of geology going on Mars. And then, of course, in 75, we sent Viking, which also sent two landers to the surface. And that was our first successful landing on Mars. And at that point, we really began to kind of understand Mars as a physical place, a real place, not some place far off and distant, but someplace that you could visit up close. And then, of course, we had basically this 20-year gap for all sorts of political reasons and budgetary reasons. 20-year gap for the late 90s, when we had Mars Global Surveyor orbiter and the Sojourner rover. That was a little, microwave oven-sized rover. That was a quest for a long time since Viking, was the ability to actually move from your landing place and go out and look at Mars. And so many of us who came along in the early space age call ourselves the lost generation, because we were forced to pretty much feed off of Viking data for our understanding of Mars for 20 years, until the late 90s, when we finally started sending spacecraft again. So we started getting a little bit better knowledge about Mars, especially with the Mars Global Surveyor. We got high resolution views of the topography. And then we sent Mars Odyssey, which gave us a little bit more compositional global data. Then Spirit and Opportunity landed in 2004. And that's where we started really, for the first time, roving over the surface, doing geology, understanding geology at the human scale. on the planet. The next mission was Mars Reconnaissance Rover. That's the spacecraft in orbit about Mars now that takes these beautiful images of the surface that look like air photos. They're so highly resolved. In fact, we use those today for planning out traverses for even for Perseverance. Phoenix was the lander that landed near the poles in 2007. And then, of course, we had the Curiosity rover in 2012, landed in 2012, and has been exploring Jezreel Crater. And let's see, in 2013, we sent Maven, which was another orbiter, which was tasked with really understanding the atmosphere. InSight was the lander that has a seismic instrument package, which we've learned that Mars's core is fairly large. And seen Mars quakes. In fact, a few weeks ago, there was a magnitude 4 over on the other side of the planet, probably in the vicinity of the canyons. And then, of course, in 2020, we have sent the Perseverance Rover. And the Perseverance Rover is tasked with actually trying to understand the past potential biology of the planet, not just the environments, but actually seeing if there are signs of organic compounds. And the goal for that mission really is to collect samples that will then be left on the surface to be picked up by a subsequent rover at the end of this decade. And that will be part of a Mars sample return plan in which those samples will be picked up by a rover, returned to a vehicle and sent back to the Earth. So that's kind of the sort of the arc of the missions that we have followed to get to this point. Okay, so a little bit about the Perseverance rover. The thing is that it's a fairly big vehicle. It's like a small car. And it has a whole bunch of instruments. It looks very similar to the Curiosity rover, but it has a completely new suite of instruments. Navcam Z is a camera system, stereo, color, that has a zoomable capability so that it can actually zoom into things at a distance. So that's been quite useful. Of course, it has Supercam, which is the laser tool that actually zaps rocks, and we use that to do spectroscopic analysis of the rocks and understand their mineralogical composition. Supercam also has a couple of other capabilities. It has a telephoto capability. It's called the remote microscopic imager. We'll see an example of that in a second. It also has a microphone for listening to the zaps that the laser makes, but it's also been used to listen to the sounds of the helicopter and driving on Mars and so on. A weather package called META, and it has a downward-looking ground-penetrating radar called RIMFAX, which basically does a view of the substrate, much the way you use ground-penetrating radar here on the Earth, as we drive along the rover. So continuously as we drive, it's doing its thing. So that results in kind of an understanding of what's underneath their wheels. MOXIE was an experiment to make oxygen from carbon dioxide, which will be very important for future missions to Mars. And we tested that and it worked wonderfully. We made oxygen out of thin air, so to speak. And then, of course, out on the end of the arm are a bunch of new instruments. There's basically what amounts to a microscopic imager. It's called Watson. And we use that to take everything from selfies by holding it up at a distance to actually looking at rocks up close to see mineral details, much the way you'd use a hand lens here on the Earth. And then, let's see, part of that package is a thing called Sherlock, which is ultraviolet spectrometer. And it's capable of identifying organic compounds and other details of mineralogy that are very difficult to do with just a lot of the other instruments we've sent to Mars in the past. And that'll be important for looking for signs of ancient microbial life. Pixel is basically the device we use to analyze rocks for their elemental composition. So we can find out, the silica content, iron content, and so on. And so that's the extent of the package on the rover. We also have two Navcams, which are color, lower resolution than the mass cam, that we take 360-degree panoramas at the end of each drive. And those are really much higher resolution than previous nav cams on both the Spirit, Opportunity, and Curiosity. And so those have proven quite useful. And I use those on a daily basis for my science investigation. Then, of course, last but not least, is Ingenuity, which is the helicopter, which was attached to the bottom of the rover, and we deployed it on the surface shortly after landing. And it was the first attempt to see how aerial vehicles might operate on the surface of Mars. It's a coaxial helicopter. It's about the size of a tissue box, but with like 4-foot blades. They have to spin very fast, and the atmospheric pressure, which is 1/100th that of the Earth's atmosphere. But we've shown that works, and we'll see some videos of that in operation in a second. So anyway, the whole idea is that we're basically going there to try to understand if there was basically we're basically going there to collect samples and set those up for return to the Earth. Understand what the context of those samples is. We need to understand the geology, so that's why it's important to do geology along the traverse, and then of course the biology. We want to really determine whether the conditions were present for past life, and explore the rocks associated with that. And then, of course, prepare for humans. That's part of what MOXIE is all about, of course, with the attempt to make oxygen. Anyway, the way the sample return works is we collect samples and we literally leave them on the surface at a couple of places. And then later in the decade, another rover comes along and retrieves them and returns them to a launch vehicle, which then goes back into orbit, rendezvous with an orbital vehicle and Earth transfer vehicle. They get returned to Earth. And so we have these nice core samples that we've collected along the way, returned to Earth. First samples that we know exactly, the context and so on. We have about 38 samples that we can bring back. And so we'll play. We have a lot of margin. We can do like 20 of them if necessary. And so those would come back sometime like 2030 or something like that. Okay, to get back to where we landed, here's where we landed with Perseverance in the yellow dot on the northwest rim of a place called Isidis Planitia. And it's an old impact basin, now much eroded. This is some of the oldest terrain on Mars around the margins. And there's lots of evidence for past fluvial activity and water. Also in this side of Mars, this hemisphere, this is down here in the lower right is where Curiosity landed in Jezreel Crater in 2012. The InSight lander landed a little bit to the north of that out in the Elysium Planitia, and has been studying the seismicity of Mars since then. And then up here to the north is where the Chinese rover Zhurong landed a few weeks after Perseverance and is now exploring the surface of Mars. It's kind of a Spirit and Opportunity heritage rover with solar panels and about the same size and a lot of the other similar characteristics. And that's still operating on the surface of Mars. So now we're going to zoom in and look at what's special about this place where we sent Perseverance. And so here it is. We landed inside a thing called Jezreel Crater. And the thing about Jezreel is that it's a place where we see evidence for a lot of potentially a past body of water ponding inside the crater. Now we'll look at that up close in a second, but just to give you an idea of the scale, this box here is the same scale as this box I've drawn around Albuquerque on this Landsat image here. So you can see what the scale of this terrain is that we landed in. This is where we landed And we're trying to get up to this feature up here. But anyway, that's the scale. So both of these images here are close to 50 kilometers across. And so that's kind of gives you an idea of the scale on Mars of some of the features we're looking at. So now let's zoom inside this box and understand what we really went there to look at. Let's see, I think I went one too far. Yes, here's the box that we just looked at. There's where we landed. So here's a zoom in of that box. So the deal with this area is that here's the rim of Jezreel Crater. And there's this big channel that enters it from the west. And at the mouth of the channel is what appears to be a river delta. And of course, river deltas form where rivers with lots of sediments enter standing bodies of water, and all the sediments suddenly slow down and fall out of the water suspension and build up a prograding feature that we here on the earth call the delta, like the delta at the mouth of the Mississippi or the Nile. So those are excellent places for preservation of lots of things because it's very fine sediments, very gently deposited. It's not, rapidly moving water. So if you wanted to look for fossils, deltas are a place where you might go. And in this case, we're looking for microbial evidence, so that's just as well. So really fine-grained sediments, lots of preservation over a couple of billions of years since this channel flowed, which probably flowed 3.8 to 3.5 billion years ago, before Mars dried out when Mars was still very wet. Anyway, this crater was filled with water. And as it dried up, of course, the delta was eroded. And later, lava flows flooded the floor of the crater. So that's what's going on out here. And where we landed was pretty much on the edge of one of these crater floor covering lava flows. And we've been exploring this area right here. And eventually, we'll work our way towards the delta. Of course, the landing was fraught with all sorts of exciting peril. This is a view up from the rover, looking up at the suspending rocket pack that lowered us down to the surface as it hovered over the surface on the day of landing. So that was our first view of this process actually in operation. And once landed, of course, we were landed in a beautiful spot. The lander was actually tasked with actually finding a very smooth place. Had a lot of artificial intelligence, so it moved around and hovered until it found a place, and this was perfectly flat, perfectly geologically boring place, but safe. And over here you can see our the blast marks on one of the sets of rocket engines. There's another set over on the other side of the rover on the right. But so here's where we landed, the landing site. There's the rim of Jezreel Crater out there in the distance. And there's the margins of that delta, that river delta out in the distance. And we're sitting on that crater floor lava flow region. So here's what we're looking at here. Here's the overhead view again. So here's the delta. This feature right here is this guy out here. And then this feature here are the edge of the delta over here on the right. So that gives you an idea of what we're looking at from our location here. We spent the first 90 sols setting up to deploy the helicopter Ingenuity. And so here it is. So again, there's our blast marks. There's the rim of Jezreel Crater. And the helicopter was unfolded from the underneath the rover and dropped to the surface. And so we drove over here and got a selfie of this historic occasion of the first aerial vehicle sitting on the surface of Mars. Then we drove off to a distance safely to observe the first flight attempts of the helicopter. And so here's our view from a distance. So there's the helicopter sitting way out there. This is a Navcam image, and they're kind of like fisheye lenses, or wide-angle lenses. They tend to make things look far away. We're only about 60 meters away here, but Still, that's pretty far away, and we can zoom in on that with the Navcam Z. Again, remember that's the zoomable camera, and there it is sitting out on the surface awaiting its first flight on Mars, which it executed successfully. And we went on to do 13 of those. And so the next image is from the third flight, looking down with our colored camera. There you can see the rover tracks. Here's the helicopter shadow. There's one of the foot pads. There's the other foot pad. So that's what the surface of Mars looks like from about 10 meters up. Looking down on this terrain that has these strange kind of paver-like joint blocks of basalt on the surface with lots of regolith and dust and fines in between. The interesting thing is that in the next on this next flight, we actually got an image of the rover from above. So this is another color helicopter image. There's the rover up in the lower left, upper left-hand corner, and here's a zoom in of it. So there it is. There's proof that the rover was on the surface of Mars. And of course, it's in the distance here, so it's kind of a grainy at this scale. This is the back end of the rover, and the front of the rover is up here, so it's kind of looking over its shoulder at us here. And altogether, this kind of grainy image, and it looks like it's looking furtively over its shoulder as it tries to escape from our view. So it kind of reminded me of something. I don't know. I was just thinking, it just looked like a famous image there. But anyway, so here's the fifth flight. We flew way out to the south with the helicopter. You can see it flying along here, flying this path that I've shown here in the main slide. And there it is going up. And it's basically specking out this train. It never had landed there before, so it wanted to see if it was safe. So there it comes in for a successful landing on its fifth flight, place that had never been. So that tested the capability of actually going out and landing in a new place on Mars. And subsequently, we've done many even more ambitious flights. For instance, here's the overhead view of our traverse throughout the first 238 sols. And there's the delta again, and here's the lava flows out here on the crater floor. Here's a very rough terrain that I'll talk about in a second. The little green dot, the white dots represent places where we stopped along the drive, okay? And the green dots represent places where the helicopter has landed. So it flew out there, and that last one you just saw was this one right here. And then it flew here, here, here. And then from there, it flew out across this escarpment here, out across this Badlands, all the way over to here. Meanwhile, the rover was moving along here, and so we didn't see the helicopter again for many sols until we got way over here. But anyway, I wanted to show you what the view looked like from the helicopter at this location as it flew over this place where we had previously been parked. In a second, I forgot, I got this slide in there. Every time we drove along, by the way, we would stop and we'd take our Navcam panorama, and there's the helicopter sitting out in the distance. It's kind of like photo bombing every single panorama we took. So the entire traverse along there, every time we stopped, we would see the helicopter sitting out there like we were basically being, I don't know, chased by the helicopter as we drove along the surface. You'd think there were like, dozens of these helicopters from the way we saw them everywhere. But anyway, so I wanted to show you these are the images taken by the helicopter, color images. Then it took downward looking black and white images called Navcam. And those were actually turned into movies, which we'll see one in a second, because we took those continuously. And I wanted to show you this image right here as we flew over a previous location. So we took off from here, flew over here, and we were doing this long traverse across the Badlands. This is the color camera view, and I've placed the model of the rover in a position that we occupied previously before the flight. You can see our tracks here to give you an idea of the scale. And then it flew basically, it took off from there and flew, and I'll show you now the Navcam movie of what it looks like to fly in the Mars helicopter. So here it is taking off. So it's gaining altitude here. There's our tracks up here on the top. And now it's going to start translating towards the southwest. So it's driving now, flying across our previous location. That's where we were when we took that color image. It's flying out. Here's the escarpment right here, and it goes along here. So it's stopping here and getting a good estimate of the terrain here in case it has to come back. And so then it decides it's ready to go, and so there it goes, flying all the way across this Badlands on one of the longest flights yet. And this this movie goes on for several minutes, basically, as we fly out across, pretty much a terrain of dunes and isolated outcrops, all the way over to the other side, and land on an escarpment way over on the other side of the Badlands here. And so this is the color image here, looking out across the Badlands. There's the escarpment where we were flying to when this image was taken. There's the rim of Jezreel Crater. There's the delta in the distance. So this is what it looks like to fly over the surface of Mars at about 30 meters. Also, when we got to the other side, we did some more flights. And during this flight here, leg here, flight number 10, I believe it was, we took a look back in this direction. The rover was parked way out there in the distance. And you can see the rover again sitting out in the distance. So there we are. We had actually successfully almost caught up with it. So you can almost hear the helicopter jeering at it, slow poke, it's like tortoise in the hare or something, the way it takes so long to get to the same location. So the helicopter shows, it can get to places very fast compared to a ground roving rover. Some of the other things we've been doing, of course, is just kind of understanding local geology and the zoomable capability of Navcam. We were able to look at the remnant of the delta, and you can see all sorts of structures. Looks like something from the Rio Puerco here. I mean, there's clearly horizontal bedding and then cross bedding in a previous package with an unconformity in between the two. And then a previous package of horizontally bedded deltaic sediments. And there was a recent science paper that came out that talked all about this. And there's all sorts of stuff going on in here. The mountains in the background, by the way, are the rim of Jezreel Crater, to give you an idea of the size of the rim. The other thing we've done is use, the Supercam's telescopic capability to look in the distance at other parts of the delta. And here's what it looks like. It looks like kind of like a spotting scope, and we can look in the distance. And this is about a kilometer away. And this is what the images look like. I mean, so that's pretty high resolution. Again, layered sediments. There's a channel here with boulders on the order of a meter across, which supports the idea that as the lake level was starting to drop, more sediments came in, but as catastrophic floods carrying immense boulders. So there's all sorts of things to learn here, and it'll be exciting when we get over to the delta. Also, every day we take panoramas. Most of them are photobombed by dust devils. So these are just simple Navcam panoramas. And every afternoon at about 2 o'clock, there's some dust devil moving around on the floor of Jezreel Crater. So one of the most dust devil infested places on Mars. And, these dust devils, of course, are the same scale as the ones here in New Mexico. Identical size, speed, all that. It's just that the combination of the fine-grained particles on the surface of the dust works with the low-density Martian atmosphere, but yet the high intensity of heating of the ground from the sun to generate, basically the same scale features. So with a captive audience, I have to talk about my investigation on the mission, right? Okay, so I'm kind of tasked with doing field geology on Mars. And so one of the ways I'm doing this is by categorizing how much you basically understand the geology at your feet. And of course, close in, you understand it very well. Then as you look further out, and that's what these concentric lines represent, you have lower resolution. You aren't touching the rocks like you are at your feet, so you're kind of guessing a little bit more. So I developed these, 5 levels of basically understanding of the local geology, with the closest end being level 5, being very well understood, pretty much like, understanding the outcrop at your feet. So that's what's going on here. So you can map out the geology inside this circle defined by your limited vision, and basically come to an understanding of the local geology, kind of like field reconnaissance geology, exactly the way you do it here on the earth. You look at the rocks at your feet, project that out around you, and understand as far as you can see, what you're looking at. So that's called, I call that GXM, which is what this little logo is, geologic context mapping. And let's see, the other thing to point out here is there's a kind of a dotted line here. That's the traverse that RIMFAX makes. So remember the ground penetrating radar. So as it drives along, it's looking down at the layers in the substrate, so we can relate all of this stuff we're seeing at the surface to what is actually underneath our feet. So we can do true geologic cross sections. And of course, we do this sort of mapping all along the drive. So you end up with this noodle that goes out to 120 meters, but really works well out to about 30 meters uh, uh, around either side of the rovers. So we developed this long geologic map. The way it works, of course, is you in a particular location, you map out the geology that you can see. You're actually touching the rocks, you're measuring them, you're analyzing them, so you can say, oh, I know what this outcrop is. This looks very similar to it, so that's probably the same thing. And then out in the distance, you can kind of guesstimate things because we have our zoomable Mastcam Z, so we can look at things far out in the distance. In this case, big basaltic blocks with vesicles or gas bubbles sitting out there in the distance, forming sort of a ridge that's out there. So you can map all this out on these overhead views of those Navcam panoramas, which we can turn into these digital elevation models, superpose the image information on top of that, and fit it to a orbital image, and then I can map the geology that I see around me on that. And so that's what's going on here, and the different colors represent different types of rocks that we had visited and understood. So here's the final result. As of Sol 238, a long geologic strip map noodle along our traverse for about not quite 3 kilometers over the surface of Mars. So this is our traverse again. So we've actually gone way out into this Badlands on our latest leg of our journey. Okay, back to looking at some scenery. So here's a Navcam panorama on Sol 110. We were parked next to this impact crater, and it had a lot of big blocks thrown out on it. And one of the blocks looked like this. And so I thought I'd talk about this a little bit. It's one of the problems we have on the mission is we have a lot of sedimentologists who are looking at the sediments but not volcanic rocks, and so everything they see is a sediment or something else, but rarely volcanic. But then, of course, those of us who are into volcanology see a rock like this and we say, aha, these are like the ropey textures on a fresh volcanic lava surface. This must have been buried in the substrate, in the impact crater. It was preserved in an impact crater through the block out on the surface, and we're seeing it. You can see vesicles on the side. Man, if I were walking along in the field and I saw that, I'd say, a block of basalt with some of the original surface texture on the surface. However, many of the rest of the team say, well, wait a minute, we know that wind abrades rocks on Mars, so maybe these are just wind abrasion marks. Maybe this is really a clastic sediment, and that it's, I don't know, these are just vugs. They're not, vesicles. And and so on. So it raises the question: when do you know something, and when do you not know it? And I think the answer I'm coming to is that it's all about context. A lot of us use context to understand the world around us, and context can also depend on your familiarity with things that have that context. In this case, volcanic rocks. So to me, I have absolutely no trouble saying 100% that this is a block of basalt, and this is very likely, if not 100%, to be the surface texture of a basalt. So, it raises the question of, how we understand things, how we know things, how do we reason the correct answer to things. And, we have a similar problem often with the public, but at a much different scale when they, interpret, something as, aliens or, Bigfoot or something. Uh, when, just a little bit more reasoning, you can put it in context and kind of understand it better. But even within the sciences, here we are, a bunch of scientists intimately familiar with geology, if not all aspects of geology, who have radically different views of something that to one geologist is perfectly obvious. So, there's variable scales of this, ability to understand and reason things, I think. So this points that out. And we've just had that problem in spades on this mission because we're walking on what are fundamentally basaltic lava flows. We've got a lot of sedimentologists, and so it's really causing all sorts of problems. But anyway, to get back to scenery, so traverse, here's another just scenic view looking over this escarpment. Here's the escarpment out here. This is what looks like the drive over the surface of Mars. Oh yeah, the block on the margins are some blocks that are tilted. But if you look at it close again, to me, that's a block of basalt. You can see the vesicles. It's even got kind of a rough surface, another preserved surface apparently, and it's tilted over along the escarpment. Let's see, another view of the surface, what it's like to be on Mars. Here's the rover on Sol 135 or 7, I believe it was. Looking at an escarpment over here, you can't see these over here. It's behind this ridge, and these dunes are just over the ridge. So you're looking at these rocks here. These are our dark, massive blocks that are sitting on top of these more or less polygonally patterned, fractured, jointed blocks. And this is kind of an interesting problem that we've encountered, that basically these rocks down here and these rocks up here are chemically and mineralogically the same. um, but yet they have such radically different expressions in the outcrop. These are big, massive blocks with vesicles. These are very coarse, granular. I mean, they almost look like sandy granite. They're so gritty and granular looking, very weathered. And then they have, on top of that, these strange little dark nubs that are vesicular and totally unlike the rock that they're sitting on, but they grade right into one another. So it's like this very flat plane here that is some sort of contact where the same rock changes its expression as we go down. So many of us think it must have something to do with a weathering horizon. These are much less weathered. These were basically soaking in fluids or something and corroded. Don't really understand it yet. We're working on it. We've only abraded a couple of examples of this and analyzed them, so that's basically going to be a big thing to come out of this first traverse. Anyway, further on, we actually stopped at some of these polygonal rocks, and there's our dark, massive ones in the distance again, and decided to do our first core sampling. So first we abraded the rock to kind of look at it, with a hand lens. So you can see there we've abraded it. We've got lots of dust on it. We have this tool that we can blow all that dust off. Rather than brush it off, we actually have a little nitrogen puff that we hit it with. And so here it is. There's the abrasion, and there's the puff blowing the dust off. It works wonderfully. So it's much better than a brush, and it cleans the surface off, and it's been very effective. And so anyway, now we can zoom in on this spot after we blow the dust off and look at it with a microscopic imager. And here it is. You can see it's a very unhappy looking rock. There's lots of dark iron stained looking matrix between grains. Some of the white stuff is not feldspar, but it's actually sulfates and other weird compounds. There's a lot of pyroxene in here, so it's a very unhappy rock. Looks like a typical, very deeply weathered rock to me. Although again, the sedimentologists think it might be a clastic rock. So that's sort of a continuing story. Anyway, so there was this rock right here that we abraded. So we liked the looks of that, so we decided we would do our first attempt at core sampling. So we got out our coring drill, and so here's an animation showing the core actually operating on the surface of Mars. And so, yep, it's working, kind of like a dentist, operating his drill before he goes in. And so then we drilled into the rock. And so here's the hole that we drilled, and it had this enormous pile of tailings. And we got through, got the sample tube out, looked down, yep, it's empty. So then we looked in the sample tube, and sample tube was empty. It's like, what happened to our sample? We looked all around, what did it fall out or something? We were kind of suspicious because these tailings are awfully big. And we suspected what happened was that this rock is so corroded, so rotten, that it basically just pulverized during the drilling process and exited the drill hole as tailings. And so we ended up with an empty first attempt at coring. However, as you well know, at this point, you say, you know how the storyline goes. If I don't know, therefore aliens, right? That's right. We don't know what happened to it, but consider this. What if aliens? Anyway, what we really think was that the rock was just very rotten. It was the type that we here on the Earth call saprolite. Anybody from the southeastern United States knows what that is, where granite looks like it's sandstone. It's so corroded. Anyway, this is an earlier example of that rock that we drilled in. You can see that the blocks, the joint blocks, have corroded rims. It's very similar to rocks here in New Mexico, where this example was in a Ice Age lake. It's a piece of basalt, actually, very dense, dark basalt, but now it's all corroded looking and very granular. And even the Sandia granite is a good example of the process where the granite is a dense igneous rock, but due to the fact that it was soaking in water it was at the base of an ocean 300 million years ago, right? Left the limestone at the crest of the Sandia Mountains. It basically corroded the rock to the extent that it's kind of gritty. It has all the sandy soils that develop around it, which is a thing that we call grus. And so I think that's what's going on with some of these rocks. They saw a lot of water, and they soaked in it, and it's basically rotten. Okay, so that was over here where we did that coring exercise. Then we drove along this escarpment here. And along the escarpment, we spied this beautiful exposure of the upper, dark, dense, massive rocks, and some of these gritty rocks that we had just cored down here, exposed in section. And you drive up to them, this is what they look like. So here's the basaltic rocks on top. Here's the very corroded looking, eroded, weathered rocks on the escarpment. And so this is a typical outcrop in early Mars, because Mars was just so wet. It's like the granites of the southeastern United States. It's just it saw a lot of water in its previous history. Here's a little fault scarp, or probably more adequately described as a slump, that you can see in the orbital image here. So just an example of some of the details. So anyway, we drove along and we drove up on top of that escarpment to get to that nice dense basalt, because we figured, well, maybe that would be something that we could actually sample. So the dense rocks are shown in my map here with the red blobs. Drove up to one here and did an abrasion. It looked good. Did 2 cores on it and got these beautiful holes. Did a selfie of the historic occasion and looked into the core tube. And this time we had a core. There's the rock, and you can see it actually looks kind of similar to that braided sample, right? But not quite as gritty looking. It's still holding together pretty well. It made a nice core, so we sealed it up. There it is, sealed. So that was the last time you'll see that sample until it returns to Earth sometime in the next decade. Otherwise, it's now sealed up, stored on board the rover, and after we collected a few more samples, we'll deposit those in a place to be picked up by a later rover. So coming to the end of the presentation here, but I wanted to show you one very interesting thing. So that was down here. Then we, from Sol 199 to 200, we did this epic, nearly 165-meter drive. And we have this thing on the rover called AutoNAV, which is where the Navcams are used to really understand the terrain in front of the rover to allow it to do autonomous driving. So it drives itself, and that allows us to drive great distances that we weren't able to do with previous rovers. So what I'm going to do next is show you a movie looking from the nav cams as we drive along this route. You can actually see it dodging some of these rocks here as it moves along. So here's the movie. It's driving itself across the surface of Mars. You can literally see it approaching rocks and turning around them, swerving in between them. And we're driving way up here to where we're going to stop. And then we're going to swing around and drive over the escarpment down into the interior over here. So that was the rover driving itself. So we drove into the interior. Let's see, I missed my map here. So that's where we were there. We drove down here, drove out into the interior, and that's where we've been since Sol 210, the beginning of October, basically, because solar conjunction began, and it's lasted until basically 2:33. And the past 3 days, we've been kind of doing some house cleaning and setting up shop again. And show you a picture of what it looks like sitting here. So here's that Badlands. There's the escarpment we drove along. So we're out here into the Badlands. Here are the rocks up here, very dense, dark looking things. I think they're ash falls. The sedimentologists think they're sediments deposited in a fluvial system. So anyway, that's where we are on Mars today. And we're going to be basically staying here for the next couple of weeks as we try to core one of these rocks or something similar. We're actually going to drive over to this outcrop over here in a couple of days and do some coring, and then we'll come back out. And it turns out this terrain is too rough to drive over because we want to get over here. So it turns out it's so rough, take us so long to get across it. It's easier literally to go back and drive around it. So that's what we're going to be doing over the next several months until February. We're going to be driving back the way we came and then past that around the eastern edge of this Badlands area and then approaching the Delta by beginning of next year. So stay tuned for all sorts of epic drive adventures. This will be a big driving trip as we drive along. You know, when we get in some of the smooth terrain, we're going to use AutoNav and drive 300 meters or something that's deadly to my mapping project, because once we get beyond about 120 meters, I kind of lose sight of the previous location. So it's going to make my map very staccato as we move along here. But anyway, we'll see lots of new and interesting things. So that's pretty much it. And I wanted to point out that I've got a book coming out. In theory, it's supposed to come out in November. With all the supply chain issues that booksellers have been having, I'm wondering if that's still viable. But anyway, it's about the history of Mars exploration, particularly what it's like to explore Mars, and lots of color images, lots of personal stories about things along the way, and so you might want to pick up a copy and tell your friends about it. So it's going to be coming out shortly, and I think there'll be a book signing, or at least there's a book signing planned at the museum in December or something like that. Anyway, with that, I'll stop and take any questions. Back to you, Dave.
Okay, that was. I think I'm unmuted. That was fascinating. Uh, I had a question. So, looks like there wasn't much to do during the conjunction that just ended.
Yeah, we actually did lots of stuff. We did the change detection with the Navcams, and we did some atmospheric observations and all sorts of things that are low risk and automated. And we started getting that data back about a week ago, um, as Mars appeared on the other side of the sun. But we just don't do any commanding or anything exotic until we're within a few degrees away from the edge of the sun.
Okay. There's a question in the chat. Tish Morris asks, how big was that volcanic rock with the striations on the side?
Yeah, I think it was like 2 meters across, so it's like 6 feet, 6 feet long. So it's a big block sitting on the rim of that crater.
Wow. And Randy Truman asks, how high are the crater walls above the landing site?
Yeah, good question. They're a couple of kilometers. I mean, it's like the Sandias, basically. I mean, we're talking big, I mean, it's a 50-kilometer crater, and although it's been filled in with lots of sediments and obviously lava flows, at least I think obviously, the it's still 2 kilometers high to the rim. So we'll be climbing a lot as we go up on the delta and using that as a ramp, eventually passing up that channel into the outside the crater.
I've got a question about Twitter. Let me share screen. Here we go. So there's a Twitter account called Percy the Mars Rover. Do you know anything about the people that do that, or
Yeah,
um,
that's from the Public Information Office at JPL, and so they kind of off on the side doing that on their own. They
they
probably
have some
have.
pretty funny stuff.
Yeah, they
Uh,
do. Yeah, yeah,
here's here's the landing,
yeah.
and then they had, I guess, one of the recent ones after the conjunction. I guess bad things happened during the conjunction.
Yeah,
Yeah, it was pretty funny. So yes, I follow Percy on Twitter.
yeah. That's it's almost a separate mission in itself. The people who are running that Twitter account, we very rarely interact with any of those guys on the mission itself.
Alrighty.
Larry,
Yeah.
this is John Covan. I
Yeah.
just wonder about your sample containers that are going to be sitting there for several years.
Hmm.
Is there a possibility that they will get covered up with dust from the Martian storms?
Yeah, I mean that all of those scenarios have been thought about. Yes, there's it's a possibility, although very unlikely because sand doesn't move that frequently in that much, in that quantity on Mars. So even if there were a global dust storm, the probability of this tubes being covered to the extent of not being recognizable is extremely remote. Yeah, so we considered those contingencies. They're perfectly sealed, so they're perfectly fine for years and years on the surface of Mars.
This is Jerry Aldridge. I have a kind of a follow-up. Uh, has the motion of the dunes been monitored in whatever way you can from orbit or from surface to know whether a dune might cover some of those?
Yeah, we've observed the dunes over the course of many years moving marginally, and we've observed small ripples, centimeter scale ones, moving a few millimeters during global dust storms. On Spirit, we were looking out in front of the rover during the dust storm, and we could see the ripples in the surface actually move a few millimeters. But yeah, things just don't change very much, very quickly.
Has the regolith in the dunes been sampled? Or you plan on doing that?
Yeah, let's see. I know we've looked at it with Supercam and measured the composition. It's just basically Martian sand, which is kind of globally homogeneous. It's like olivine-rich basaltic sand, and the dust
Okay.
is like amorphous, basaltic, high silica stuff.
Marilyn, Savick Crane had another question. Have you ever talked to the Chinese, and what have they done so far?
Yeah, so the question was, have we ever talked to the Chinese? And the answer is no. We have not heard much of anything from the Chinese. Um, I'm sure you'll learn things about the Chinese mission as soon as we learn anything. It's basically every now and then they send out these kind of public releases, and they're very few and far between. They're very hold all of their information very close, and yeah, we just don't know very much about what they're doing or any of the science going on. But they must be doing something. They've driven several hundred meters over the surface. They have some interesting instruments. They even have something like the RIMFAX, but I haven't seen or heard anything about the results from that. So maybe at the next Lunar and Planetary Science Conference meeting in March in Houston, maybe a couple of representatives will show up and give us the full scoop on that. But yeah, they're very good at taking advantage of previous missions design, and but not really sharing a lot. I mean, frankly, some of the details of the rover are so similar to the Spirit and Opportunity. It's just appalling. but they seem to be comfortable with doing that. I mean, I guess it's fair game or something. They don't have to go through all the details of designing these things.
Interesting. Randy has another question about dust devil size and speeds. You mentioned they're similar to Earth, but with a much lower atmospheric density. Are the particles much smaller in a dust devil?
Yeah, our dust devils are like silt particles and even sand particles. If you've ever stood in the middle of one, you can feel the grit, taste the grit after it's passed. And on Mars, it's mostly, we think it's mostly dust, although, we have experienced a couple of dust devils passing right over Spirit and Opportunity. And it's curious, we have a lot of sand on the decks, surfaces of both of those rovers after the dust devil passes through. So clearly, dust devils are able to probably move around sand-sized particles by saltation process that it basically allows sand dunes to form on Mars. So, but by and large, the big column is mostly micron-sized dust stuff.
That's probably smaller than here on Earth.
It's like it's kind of like the dust that gets on your coffee table or on your your outdoor furniture every day here in New
Oh, okay.
Mexico. I mean, New Mexico is such. Everybody gets tired of me saying it. Mars is like New Mexico, but just more so. It's very dusty, and here in New Mexico, I mean, we're just so used to dust, and it just rains out of the sky. Even on a clear day, I mean, you can have something out, the hood of your car, park it outside, and the next day it's got dust on it, and it's just, nothing. There was no dust storm or anything. It's just falling out of the air. And so the same thing happens on Mars. It's just that's why the sky is kind of brownish colored. It's always got dust in it, and it's always falling out, and it's very, very, it's almost smoke-sized particles. So they're floating around and falling continuously.
Fascinating. Okay. Well, that was certainly a fascinating talk, Larry. Thanks much.
Good.
Next month is going to be an interesting talk. We're going to talk about this recent paper of the Tal El Hammam site in the Middle East being a possible location of Sodom as described in the Bible. And there was a paper that came out on that recently, and Mark Boslow has been looking at, and there's some severe problems. So I've put some links on our meeting page if you want to read the article and the Nature scientific reports. It's a different journal than Nature itself, but they're connected. And then some criticism, especially about the photographic. Some of the photographs apparently were in different orientations, and there's all kinds of photoshopping going on. So it's a big old mess.
Yeah.
But in fact, one of the co-authors is one of my fellow professors here at Tech, so I probably ought to ask him if he wants to participate. But should be fun, should be interesting. So thanks, Larry, again,
You're
and
welcome.
take care out there, and we'll see you back in just a few weeks. We'll be back to second Wednesday. So take care, everybody.
Okay. Thank you.
All right.
Thanks, Larry.
Great.